Alright, today we are going to review for your Conceptual Unit 8 test. Alright, it says write the first 4 terms of the sequence whose general term is given. So they're telling you to get the next term in this sequence, take 5 times the number you're looking for, the term you're looking for, plus 2. So to find a sub 1, I take 5 times 1 plus 2, which is 7. To find a sub 2, I take 5 times 2 plus 2, which would be 10 plus 2, which would be 12. To find a sub 3, I take 5 times 3 plus 2, which would be 15 plus 2, which would be 17. And a sub 4 would be 5 times 4 plus 2, which is 20 plus 2, which would be 22. Okay? Write the first 4 terms of the sequence whose general term is given below. So we have, if we're finding a sub 1, it would be negative 1 to the 1 plus 1 times 1 plus 2. So I have negative 1 squared times 3. That's going to be a positive 1 times 3 is 3. A sub 2 is going to be negative 1 to the 2 plus 1 times 2 plus 2. This is going to be 3. 3 copies of negative 1 is negative 1. 2 plus 2 is 4. Multiply is negative 4. A sub 3 is negative 1 to the 3 plus 1 times 3 plus 2. That's 4. 4 copies of a negative is positive 1. 3 plus 2 is 5. Multiply is 5. And a sub 4 is negative 1 to the 4 plus 1 times 4 plus 2. That's 5. 5 copies of a negative is negative 1 times 6 is negative 6. You're just plugging them in and simplifying. Okay, write the first 4 terms of the sequence whose general term is given. So a sub 1 would be 2 times 1 over 1 plus 8, which would be 2 over 9. A sub 2 would be 2 times 2 over 2 plus 8, which would be 4 over 10, which reduces down to 2/5. A sub 3 would be 2 times 3 over 3 plus 8, would be 6 over 11. And a sub 4 would be 2 times 4 over 4 plus 8, which would be 8 over 12, which reduces down to 2/3. Okay? Alright, the sequence given is defined using a recursion formula. Write the first 4 terms of the sequence. If a sub 1 equals 6, and to get the next term, you take 3 times the previous term and add 5 to it. So it's telling me that a sub 1 is 6. I don't have to do any math. To get a sub 2, I take 3 times a sub 2 minus 1 plus 5. This is a sub 1, which is 6. So I have 3 times 6 plus 5. That's 18. Plus 5 is 23. A sub 3 is 3 times a sub 3 minus 1 plus 5. 3 minus 1 is 2. A sub 2 is 23. So 3 times 23 plus 5 equals 74. Okay, and then a sub 4, I have 3a to the 4 minus 1 plus 5. 4 minus 1 is 3. A sub 3 is 74. 3 times 74 plus 5 is 227. Okay? Or, yeah. Okay, so this one says, write the first 6 terms of the arithmetic sequence with the given first term a sub 1 and a common difference d. So it's telling me that my first term is 250. If my common difference is negative 80 and it's arithmetic, it means to get the next term, you take 250 minus 80. So 250 minus 80, you get 170. To get the next term, you take 170 and subtract 80. And you get 90. To get the next term, you take 90 and subtract 80, and you get 10. To get the next term, you take 10 and subtract 80, you get negative 70. To get the next term, you take negative 70 and subtract 80, you get negative 150. You just keep continuing the pattern until you get all the terms they want. Okay, write the first 6 terms of this arithmetic sequence. It's telling you that the first term is 3 halves. To get the next term, I take 3 halves and I add a half, which would be 4 halves, which they reduce down to 2. To get the next term, I take 4 halves and add a half, which gives me 5 halves. And you can keep writing out the math if you want, but all they're doing is increasing the numerator. So 6 halves, 7 halves, what do they want? 1, 2, 3, 4, 5, and 8 halves. The only thing is they reduce. So this is 3 halves, this is 2, 5 halves, 3, 7 halves, 4. There you go. Okay, write the first 6 terms of the arithmetic sequence shown below. It says that the next term will be the previous term, add 4. So to find a sub 1, I don't really have to. They told me a sub 1 is negative 6. So to find a sub 2 minus 1 plus 4, that would be a sub 1 plus 4. A sub 1 was negative 6 plus 4 is negative 2. And you can keep doing all this math if you want to, but it's arithmetic. And the common difference is add 4. So negative 2 plus 4 is 2, plus 4 is 6, plus 4 is 10, plus 4 is 14. I mean, it's important that you understand how to show the algebra, okay? But again, you're talking arithmetic sequences. It's saying the previous term add 4, the previous term add 4. So it's telling you add 4 every time, and you can get as many terms as you want. Alright, so now it says use the formula for the general term, the nth term of an arithmetic sequence, to find the 6th term of the sequence with the given first term and common difference. Alright, so we have to use this formula. A sub n, the nth term, will be the first term, plus remember, you need so many copies of the common difference to get you, in this case, they want the 6th term. So to find the 6th term, I need to take the first term and add 5 common differences to it, which makes sense. Okay, so they're giving me, so to find a sub 6, I take a sub 1, which is 19, plus 6 minus 1, and the common difference is 6. So I need 19 plus 5 more 6's to get to this would be my first term, and this would be the next 5, which would put me at the 6th term. So if you type 19 plus 30, you get 49. The 6th term of that sequence will be 49. Okay? Use the formula for the general term, the nth term. So again, a sub n equals a sub 1 plus n minus 1d to find the indicated term of the sequence with the given first term a sub 1 and common difference d. They want me to find the 150th term. When a sub 1 is negative 40, so add 150 minus 1, common differences. So I'm going to take the first term and add 149 5's so that I can get to the 150th place. This would be one place plus 149 more would put me in the 150th position. So I take negative 40 plus 149 times 5. Negative 40 plus 149 times 5. And you get 705. The 150th term in that arithmetic sequence is going to be 705. Okay, write a formula for the general, the nth term of the arithmetic sequence. So again, now we have to write our formula. Plus n minus 1d. Then use the formula to find a sub 20. So to write this formula, I need a sub 1, which is 5. I need plus n minus 1, and I need the common difference. Well, 5 to 2 is subtracting 3. 2 to negative 1 is subtracting 3. Subtract 3 is negative 4. So my common difference is negative 3. Okay, so if I simplify this end, this wouldn't be wrong. That's your formula. But all they did was simplify it. So they distributed the negative 3. 5 minus 3n plus 3, which gives me negative 3n plus 8, combined like terms. And then they just wrote it as 8 minus 3n. So now they want me to use it to find the 20th term. Well, the 20th term is going to be negative 3 times 20 plus 8. That's going to be negative 60 plus 8, which is going to be negative 52. Okay. Write a formula for the general term, same direction. So a sub n equals a sub 1 plus n minus 1d. My first term is 12 plus n minus 1. I need the common difference. And it's saying the common difference is negative 1. And see how they just, in this case, left it, they didn't simplify it. I'm assuming if they wanted you to distribute, I mean, you could, and you'd get 12 minus n plus 1, which would be 13 minus n. That would be acceptable, but for whatever reason, they said don't simplify it. And now we're going to use that to find the 20th term. So a sub 20 is going to be 13 minus 20, which is going to be negative 7. Okay? All right, wait, did I skip one? Okay, use a system of two equations and two variables, a1 and d, to write a formula for the general term, the nth term of the arithmetic sequence whose sixth term, a6, is 12, and whose ninth term, a sub 9, is 21. What? Why do they want me to use a system of equations? I don't think anyone paid attention to this one. I'm not use a system of two equations. What do they want me to do? Write a formula for the general term? Well, if your sixth term, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. The sixth term is 12. The ninth term is 21. And the pattern is 3n minus 6. So, let's see. How can we figure out the pattern here? So, I see. So if I say 3 times, wait a minute, 3 times 6, yeah, so 3 times 6 minus 6, that would be 12, right? I'm not really sure why they're wanting us to use a system of two equations. If you just use the thingy and you go a sub 1 would be 3 times 1 minus 6, that would be negative 3. And then 3 times 2 minus 6 would be 6 minus 6 would be 0. 3 times 3 minus 6 would be 9 minus 6 would be 3. 3 times 4 is 12 minus 6, which would be 6. They're adding 3 every time. 9, 12, 15, 18, 21. I mean, I'm not really sure what's going on about making it so complicated. If I want to get the general term, a sub n equals a sub 1 plus n minus 1d, to me, instead of making a system of equations, your first term is negative 3 plus n minus 1. Your common difference is they're adding 3 every time. So if I simplify that, I get negative 3 plus 3n minus 3, and that gives me 3n minus 6. Oh, because I was using that answer wasn't there, silly goose, Tamsin. Okay, let me, goofy. Sorry. I forget that you can't see that answer, and I can. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's how I would do it instead of this system of equations thing. 1, 2, 3, 4, 5. The sixth term is 12. 7, 8, 9. The ninth term is 21. If you figure out, okay, between here, the difference between 21 and 12. 21 minus 12 is 9. 9 has to be, so I have to add 9 to 12 to get to 21. But I got to split that up into 2 steps. So if you say, well, if I add half of that, well, not half of that, but the square root of that, oh, shoot, I don't know. All right, 21 minus 12 is 9. And if you cut that in 2, oh, what am I doing? Oh, 3, because 1, 2, 3 steps to get there. That would be a difference of 3. So if I add 3, I get 15. Add 3, I get 18. And again, I can use that to subtract 3 would be 9. Subtract 3 would be 6. Subtract 3 would be 3. Subtract 3 would be 0. Subtract 3 would be negative 3. So then, without knowing this, I see how I got my terms. So my general formula, a sub n equals a sub 1 plus n minus 1t. My formula will be negative 3 plus n minus 1, and my common difference is 3. So now I have negative 3 plus 3n minus 3, which gives me 3n minus 6. There's my general term. Okay? Alright. It says in 1986, approximately 14% of all teenagers had no jobs. On average, this percentage has increased by approximately 0.79 per year. Write a formula for the nth term of the arithmetic sequence that models the percentage of teenagers with no jobs n years after 1985. Well, again, if you look, my first term is 14. So if I'm trying to find a sub n equals a sub 1 plus n minus 1t, okay, my first term is 14 plus n minus 1. My common difference is that it is increasing by 0.79 per year. So my common difference is 0.79. So if I distribute, I get 14 plus 0.79n minus 0.79. Combine like terms, and 14 minus 0.79 is 13.21. Oops. So we have 0.79x plus 13.21. There's that. And then it says, if trends shown by the model in Part A continue, what percentage of teenagers will have no jobs in 2012? They're giving me a time, but you're not going to plug in 2012 because that would be finding what the salary would be in 2012 years from now. And they don't want to know that. The N represents the number of years after 1985. So to figure out how many years that is, subtract 1985. And you get 27 years. So they want me to replace x with 27. So a sub 27, in other words, 27 years after 1985, it'll be 0.79 times 27 plus 13.21. 0.79 times 27 plus 13.21, you get 34.54. And to round to one decimal place, the 4 would not bump it up. Okay. Company A pays $26,000 with raises of $1,600 per year. Company B pays $28,000 yearly with raises of $800 per year. Which company will pay more in year 10 and how much more? Well, for Company A, the nth term will be the first term plus n minus 1 d's, right? So for Company A, the nth term will be they're paying $26,000 plus n minus 1 raises of $1,600. For Company B, a sub n equals their starting point, 28,500, plus n minus 1, 800 raises. Okay? And they want me to figure out which is the better deal in year 10. So in year 10 for Company A, I'll get 26,000 plus 9 1600s, because 10 minus 1 is 9. So 26,000 plus 9 raises of 1600, 26,000 plus 9 times 1600. In the 10th year, you get 40,400. For Company B, the 10th year, 28,500 plus 9 raises of 800, because 10 minus 1 is 9. So 28,500 plus 9 times 800 gives me 35,700. So obviously, Company A pays more. By how much? Subtract those. 40,400, take away 35,700. 40,400 minus 35,700, and you get $4,700. Okay? Write the first 5 terms of the geometric sequence whose first term is 3 and whose common ratio is 2. Geometric means you're multiplying each time to get the next term. So if I start at 1, times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48. There you go. Write the first 5 terms of the geometric sequence whose first term is 81 and whose common ratio is 1/3. So times 1/3, and type it in, you get 27. 27 times 1/3, you get 9. 27 times, 9 times 1/3 is 3, and 3 times 1/3 is 1. I mean, you can use a calculator if you want, guys, but this is 81 over 1 times 1 over 3, which is 81 over 3, which is why you get 27. 27 over 1 times 1 over 3 is 27 over 3, which is 9. 9 over 1 times 1 over 3 is 9 over 3, which is 3. And 3 times 1 over 3 is 3 over 1 times 1 over 3 is 3 over 3, which is 1. Or use a calculator. Okay, write the first 5 terms of the geometric sequence. They're giving me a recursion formula, so they're saying to find the next term, you take 4 times the previous term, and that's it. So to get a sub 1, it's 19. They told it to you. So to get a sub 2, you take 4 times a sub 2 minus 1, which is a sub 1, which is 19, and 4 times 19 is 76. And again, you can keep doing this if you want. A sub 3 would be 4 times a sub 3 minus 1, which would be a sub 2, which would be 76, and 4 times 76 is 304. You can keep doing that, guys, if you want, but you know that the pattern is your common ratio is 4. So times 4 is 304, times 4 is 1216, times 4 is 4864. Okay? For the first 5 terms of this geometric sequence, and again, they're saying start at -7. And you can do the math if you want to, but you can tell from the recursion formula that to get the next one, all you do is multiply by -6. So times -6 is positive 42. 42 times -6 is -252. -252 times -6 is positive 1512. 1512 times -6 is -9072. Okay? Let's skip one here. Use the formula for the general term, the nth term of a geometric sequence, to find the indicated term of the following sequence with the given first term a sub 1 and common ratio. To find the general form of a geometric, it's a sub n equals the first term times n minus 1 copies of the common ratio. Okay, just like the arithmetic, but it was n minus 1 copies of the common ratio, t. Okay, so this one says find a sub 9 when a sub 1 is 6 and r is 4 to the 6 minus 1. So you're going to do 6 times 4 to the 5th. You got to type 4 caret 5, enter first, times 6, and you get nothing with the 9th term. Why am I getting the 6? So that'd be 9 minus 1, which is 8. So 4 caret 8, enter, times 6, and you get, there you go, 393,216. Okay, find a sub 4, the fourth term of the sequence, if the first term is 5250 and the common ratio is a sub 4. So my formula is a sub n equals a sub 1 to the times r to the n minus 1. If they want me to find the fourth term, I take the first term, which is 5250. The common ratio is 1/5 to the 4 minus 1. So that's going to be 5250 times 1/5 to the third. So if you type 1 divided by 5, enter, caret 3, enter, times 5250, enter, you get 42. Alright, it says write a formula for the general term of the geometric sequence, then use the formula to find a sub 7, the seventh term of the sequence. Alright, so to write my formula, a sub n equals a sub 1 r to the n minus 1. I need two things. I need a sub 1 and I need r. Well, I got a sub 1. It's the first term in the sequence. To get r, you divide your terms. 4 divided by 8 is 1/2. 2 divided by 4 is 1/2. 1 divided by 2 is 1/2. So the common ratio is 1/2. And there's your formula. Okay, then to find the seventh term, I plug that in. So I have 8 times 1/2 to the 7 minus 1. That's going to be 8 times 1/2 to the 6th. When you type that in, type 1 divided by 2, enter, caret 6, enter, times 8, enter. And you get 0.125, which Math Excel clearly doesn't like. So Math enter that, and you get 1/8. Okay. Find the sum of the first 12 terms of the geometric sequence shown below. 4, 8, 16, 32. So to find the sum of geometric terms, you have a sub 1 times 1 minus r to the n over 1 minus r. So to find the sum of the first 12 terms, I take the first term, which is 4, times 1 minus my common difference. I'm going to have to figure that out. 8 divided by 4 is 2. 16 divided by 8 is 2. 32 divided by 16 is 2. My common ratio is 2 to the 12th over 1 minus 2. So if you type this very carefully, and let me get my calculator up on my screen here a second. Alright. So if you type this, here's what I do. I type 1 minus 2 caret 12 and hit enter. Then I hit times 4, enter. And then I hit divided by negative 1, enter. And I get the sum, crap. Forgot I can't write at the same time. The sum of the first 12 terms is 16,308. Just type it very, very carefully. Alright, so use the formula for the sum of the first n terms of a geometric sequence to solve this exercise. They want the sum of the first 6 terms. So my formula, S sub 6, is going to be a sub 1, 1 minus r to the n, all over 1 minus r. So the sum of the first 6 will be the first, which is 17, 1 minus my common ratio, divide backwards, 14 divided by 7 is 2, 28 divided by 14 is 2, 56 divided by 28 is 2, my common ratio is 2 to the 6th over 1 minus 2. So again, if we type that, 1 minus 2 caret 6, enter, times 7, enter, divided by negative 1, enter, you get 441. Okay? Find the sum of the first 14 terms of the geometric sequence shown below. So again, we need the sum of the first n terms is a sub 1, 1 minus r to the n over 1 minus r. So the sum of the first 14 terms is going to be the first term, which is negative 3/2. 1 minus, to get my common ratio, I'm going to take 3 divided by negative 3/2. Keep, change, flip. The 3's cancel, I get negative 2. Negative 6 divided by positive 3 is negative 2. 12 divided by negative 6 is negative 2. My common ratio is negative 2 to the 14th, all over 1 minus the negative 2. Alright, so first of all, I'm going to pull my calculator up on this one too. Okay, first of all, I'm going to do 1 minus parentheses negative 2 parentheses caret 14 and hit enter. Okay, then I'm going to multiply that by negative 3 divided by 2, enter. And then the bottom, you have a double negative. 1 plus 2 would be 3, so divided by 3, and I get 8191.5. The sum of the first 14 is 8191.5. Okay? You find the indicated sum. Use the formula for the sum of the first n terms. This is the same stuff. They just are writing it in summation notation. Everything else is the same. This says that they want you to go from the first term to the 8th term and find the sum of 2 to the I. Okay? Well, first of all, I have to figure out a sub 1. So if I find out a sub 1, I plug in 1 for I. That would be 2 to the first, which would be 2. So my a sub 1 is 2. Okay? 1 minus, my r is the base of the exponent. So my r is 2 to the, we're doing 8 terms. From 1 to 8 would be 8 terms. Okay? So 2 to the 8th over 1 minus 2. So if I type that in, 1 minus 2 caret 8, enter, times 2, enter, divided by negative 1, enter, you get S sub 8 equals 510. Okay? Another one. So we need our formula. The sum of the first n terms is the first term times 1 minus the ratio to the n over 1 minus the common ratio. They want us, we're going from 1 to 10, so we're finding the sum of the first 10 numbers. To find S sub, or the first term, a sub 1, I would take 5 times 2 to the first, which would be 5 times 2, which would be 10. So a sub 1 is 10. 1 minus the base of the exponent is your common ratio to the 10th all over 1 minus 2. So if I type that in, 1 minus 2 caret 10, enter, times 10, enter, divided by negative 1, enter, you get the sum of the first 10 is 10,230. Okay? Find the indicated sum. We're going from 1 to 5, so we want the sum of the first 5 terms. My first term is, I don't know, I gotta find a sub 1. To find a sub 1, I take 2/3 to the 1 plus 1, which would be 2/3 squared, which would be 4/9. So I have 4/9 is my first term, times 1 minus the base of the power is my common ratio, so 2/3 to the 5th over 1 minus 2/3. Okay, now be very, very careful here. I better pull up my calculator. So, hold on. We're going to type 1 minus parentheses 2 divided by 3 parentheses caret 5. Enter. And then I'm going to multiply that by 4/9, so times 4 divided by 9. And then I'm going to divide that by parentheses 1 minus 2 divided by 3 parentheses. And I get 1.157750343. Math, enter that. And you get the sum, the sum of the first 4 terms are 844 over 729. 844 over 729. Yeah? And that's why I want to type it using fractions and not, I could have typed them from the beginning and got decimal equivalents, but especially the 2/3, those are going to be repeaters. And if you round off your repeaters, there's no way Math Enter will give you the right fraction back. It probably won't give you a fraction at all because you've rounded off so many points that it's not rational anymore. Okay, so be careful on rounding. All right, find the sum of the infinite. When you have an infinite geometric sequence, okay, you take a sub 1 over 1 minus r? Huh. Well, let's see. Alright, so the sum of this infinite series will be a sub 1, which is 1, over 1 minus r. my R is, if I figure out this difference, they're adding, let's see, 1/16 divided by 1/4. Oh, I can't do that. 1/16 parentheses divided by parentheses 1/4. You get 1/4. So the common ratio is 1/4. So let's see, if I do that, I get 1 over, if I do 1 minus 1/4, I get 0.75. And if I do 1 divided by 0.75, I get 1.333 repeating. If I math enter that, I get 4/3. Alright, find the sum of this infinite geometric series. Alright, if I find the sum of this, I'm going to use a sub 1 over 1 minus r. My a sub 1, to figure out a sub 1, I would have to plug in 1, so I'd have 8 times 0.8 to the 1 minus 1. That would be 0.8 to the 0. That would be 8 times 1. That would be 8. So my first term is 8 over 1 minus, my common ratio is the base of the power, so 1 minus 0.8. And if I type that in carefully, 8 divided by parentheses 1 minus 0.8 parentheses, I get 40. Okay? Alright, the general term of a sequence is given. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is arithmetic, find the common difference. If it's geometric, find the common ratio. It's arithmetic. They're subtracting. I can see it's arithmetic. But what they want you to do is generate the first few terms. A sub 1 would be 1 minus 5 would be negative 4. A sub 2 would be 2 minus 5 would be negative 3. A sub 3 would be 3 minus 5 would be negative 2. Alright, you can tell to get to the next term, you would add 1. You would add 1. You would add 1. I'm adding the same amount every time, which makes it arithmetic. And your common difference is 1. Okay? Alright, same thing for this one. You can tell because of the power, it's going to be geometric. But we've got to find the common ratio. Well, and it's 5. But anyway, a sub 1 would be 5 to the first is 5. A sub 2 would be 5 squared is 25. A sub 3 would be 5 cubed, which would be 125. To get every term, 25 divided by 5 is 5. 125 divided by 5 is 5. So the common ratio is 5, and it's geometric. I just keep skipping ones. Okay, 32. Did I skip another one? Okay, 31. 32. The general term of a sequence is given. Determine whether it's arithmetic, geometric, or neither. This one's going to be neither because I can see arithmetic and geometric in the same problem, but let's make sure. So a sub 1 would be 1 squared minus 8 would be negative 7. A sub 2 would be 2 squared minus 8. That'd be 4 minus 8 is negative 4. A sub 3 would be 3 squared minus 8. That'd be 9 minus 8 is 1. A sub 4 would be 4 squared minus 8. That'd be 16 minus 8 would be 8. If you tried to go arithmetic, the difference between, if I took negative 4 minus a negative 7, that would be 3. If I do this one, 1 minus a negative 4, I get 5. The difference between 1 and 8 is 7. It's not changing by the same amount every time. So it's not arithmetic. To check geometric, divide. Negative 4 divided by negative 7 is 0.571, blah, blah, blah. 1 divided by negative 4 is negative 0.25. Those are not the same, so it's not geometric, which means it's neither. Alright. Suppose you have $1 the first day of the month, $3 the second day, $9 the third day, and so on. That is, every day you save 3 times as much as you did the day before. What will you put aside for savings on the 11th day of the month? Okay, so we are doing we want to find a specific term just on the 11th day. We're not summing up how much you would have over the 11 days, just what you would have to put aside on the 11th day. So we want the specific term formula, a sub n equals a sub 1 times the common ratio to the n minus 1. So I'm wanting the 11th day. Well, on the first day, I only saved $1. My common ratio is 3, because you're tripling it every day, and I want to the 11 minus 1. So this is going to be 1 times 3 to the 10, which is just 3 to the 10th. And if you type in 3 caret 10, on the 11th day, you're going to have 59,000. You're going to have to set aside $59,049. Okay? Good luck with that. All right, a professional baseball player signs a contract with a beginning salary of $7 million. Jeez. For the first year and an annual increase of 14% per year beginning in the second year. That is, beginning in the second year, the athlete's salary will be 1.14 times what it was the previous year. Yeah. What is the athlete's salary for year 6 of the contract? Again, we're finding a specific term. So I want the 6th term, which is going to be the first term, which is 7 million. 2, 3, 4, 5, 6. My common ratio is going to be 1.14 to the 6 minus 1. So that's going to be 1.14 to the 5th. So if I do 7, 1, 2, 3, 4, 5, 6 zeros times 1.14 caret 5, I get the 13477,902.08, but it rounded to the nearest dollar, so they cut it off there. His 6th year salary will be 13 million freaking dollars. That's insane. All right. 35. To save money for a sabbatical to earn a master's degree, Henry deposits $1,500 at the end of each year in an annuity that pays 6.1% compounded annually. Use the formula for the value of the annuity shown at the right. How much will he have saved at the end of 6 years? And they want you to find the interest. All right. Excuse me. So we are trying to save money, and we're in an annuity, so that's the one with the payments. Okay, you're making payments. So for this case, he's making payments of $1,500, so that's your P. At the end of each year, an annuity that pays 6.1% interest, so R is going to be 0.061. It's compounded annually, so N is going to be 1, which makes things nice. And it says, that's all we know. So how much will he have saved at the end of 6 years? So we would do, the amount will be his payment of $1,500, bracket, parentheses, 1 plus 0.061 over 1 to the 1 times, okay, so for A at the end of 6 years, so time is 6, sorry, had to read there, minus 1, close your bracket, and all of that is going to be divided by 0.061 over 1. Okay, let me pull up my calculator here so you know how to type this. Alright, so here's what I would do. Turn my calculator on, clear my screen. I'm going to do the 1 plus 0.061 divided by 1, enter, caret 6, because 1 times 6 is 6, minus 1, enter. So I've done inside the parentheses. Now I'm going to multiply by 1,500, enter, and then I'm going to divide by parentheses 0.061 divided by 1, enter. And I get the 10,489.36295. And they rounded it to the nearest dollar. So I get the 10,489. Now, how much interest will the annuity have gained? Well, he's putting in, wait, how much interest will the annuity have gained? Well, let's see. What we're talking about, 6 years? Okay, so in 6 years, how much is he's going to pay? He's going to pay $1,500 each year times 6 years. So he's going to pay $1,500 times 6. His payments of this much money is worth $9,000. He's put in $9,000. Okay? If you have a total of $10,489, if you subtract off what you've put in, then the difference is $10,489 minus $9,000. You get $1,489. So you've earned $1,489 in interest. Okay? All right. This one says 2 ways of investing $50,000 for 20 years are shown below. After 20 years, how much more will you have from the lump sum investment than from the annuity? Okay, so if you take a lump sum deposit of $50,000 at a 3% annual interest rate and your time is 20 years, okay? For that one, you're going to, a lump sum, you're just compounding annually for 20 years, you can use the APERT formula. Okay, and so for the lump sum, I'm going to say that the amount will be his deposit, $50,000, 1 plus 0.03 for 20 years. So if I do that math, 50,000, 1, 2, 3, parentheses, 1 plus 0.03, parentheses, caret 20, I get 90305.56173. That will be if he just does a lump sum for 3% for 20 years. If he makes $2,500 deposits at the end of each year, compounded annually for 20 years, okay, you're going to have to use this formula. So you would have A equals his payments, which are going to be $2,500, bracket, parentheses, 1 plus 0.03, compounded annually means n is 1, which makes the math nice, to the 1 times 20, minus 1, close the bracket, all over 0.03 over 1. Okay, so again, let me pull my calculator up here. I would type 1 plus 0.03 divided by 1. I know that's kind of silly, but in case it's not so simple. Caret 20, enter, minus 1, enter, times 2,500, enter, divided by 0.03 divided by 1, which is just 0.03, and you get 67175.93622. Okay, so for this one, we get the amount is 67175.93622. So if I take the difference of these two, okay, obviously you're going to get more money if you just put it all in at once instead of breaking it up and putting in $2,500 in a month. Okay, so the difference between those, if I take 90,305.56 and take away 67,175.94 if I round, okay, if I subtract those, 90,305.56 minus 67,175.9362, you get 23129.62551, and it says round to the nearest dollar. So this 6 would bump up this 9 to a 10, carry over, makes that a 3, and everything else comes down, and that's the $23,130. Okay? Alright, a new factory in a small town has an annual payroll of $9 million. It is expected that 75% of this money will be spent in the town by factory personnel. The people in this town who receive this money are expected to spend 75% of what they receive in the town, and so on. What is the total of all of this spending, called the total economic impact of the factory, on the town each year? Use the formula for the sum of an infinite geometric series. And the sum for the infinite geometric series is a sub 1 over 1 minus r. So let's see, we are starting off with 9 million. Right, and our common ratio is 75%, so 1 minus 0.75. Okay, so if I do 9 million, 1, 2, 3, 4, 5, 6, divided by parentheses 1 minus 0.75, you get not the right answer. All this spending. Why did I get, let me do some more. Divided by, no, that's not it either. If they're going to spend 75% of that money, so the common ratio is 75. I'm going to have to check on this one. Let me finish up the last one and then I'll see if I can't figure that one out. Okay, if the shading process shown in the figure is continued indefinitely, what fractional part of the largest square will eventually be shaded? Well, what you're doing here is the first time you shaded, you would only shade 1/4 of the whole square. The next time you break those down, right, and you shade 1/4 of, hold on just a second. Okay, we're back. All right, let me back up here. Okay, yep, here's where I screwed up. I can't erase that, Townsend. We forgot to find the first term. Yes, it's 9 million, okay? But 9 million is you're going to spend 75% of that. So if I take 9 million and I multiply that by 0.75, 9, 1, 2, 3, 4, 5, 6 times 0.75, I get 675, 1, 2, 3, 4 zeros. That's going to be 1 over 1 minus the common ratio, which is 0.75. So if I do that, 675, 1, 2, 3, 4 zeros divided by parentheses 1 minus 0.75. There we go. I get the 27 million each year. Okay. This first time you took a square and they shaded 1/4 of it. So there's my first term. The second time, just in this quarter, they shaded 1/4 of it. So wouldn't that be, to get my next term, would be 1/4 times 1/4 of a fourth. So times 1, that would be my first term. The second term would be, I'm coloring 1/4, I've already got 1/4 plus 1/4 of a fourth. So that would be 1/4 plus 1/16, which would be 1 divided by 4 plus 1 divided by 16. Math enter, you get 5/16. My next term would be the 5/16 plus 1/4 of a fourth of a fourth, right? Because this one would be a fourth of this fourth, which is a fourth of that fourth, I don't know if I'm doing this right or not. 5/16 plus 1 over 64. So 5/16 plus 1 over 64. Math enter. You get 21 over 64. So I'm doing a sum, which would be a sub 1 over 1 minus r of an infinite series. So my sum would be 1/4 over 1 minus, what's my common ratio? Well, if I do 5/16 divided by, I use parentheses, 5/16 divided by 1/4, get 5/4. So this is going at, no it's not. That went up 5/4, then, oh, it's geometric. What am I doing? Maybe this would be a fourth of a fourth of a fourth. Would be 1 over 64. I'm just playing here, guys. I'm not really sure what I'm doing. So then the next, so if I did that, 1 divided by 64 divided by 1 divided by 4, going up by 1/16. I'm just going to try this and see if it comes out right. So I've got parentheses 1 divided by 4 divided by parentheses 1 minus 1 divided by 16 parentheses. I get 4/15. You know what? Extra credit for anybody who can figure this out and explain it to me. I didn't put this one on the test, don't worry. Alright, we are done. So please, please, please review carefully. You need to do well on your test. And happy homeworking, study hard, and I will see you next time.